Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 438, find all anagrams in a string. This is a medium difficulty Leetcode problem, and we're told in this problem that we're given two strings, s and p, and we want to return an array of all the start indices of p's anagrams in s, and we may return the answer in any order. So this kind of problem, we've seen it before. The problem description is similar to permutation in string, and believe it or not, it's the exact same solution. It's kind of a sliding window solution that we need to implement to solve this problem. But let's carry on walking through an example. So in this example, we return an array in our output with two indices, and these are the indices of the substrings which form an anagram. So index 0, CBA, is an anagram of ABC, and so is BAC. So we return the indexes 0 and 6. And to solve this problem, again, like I said, we want to use a sliding window problem. We want to have a fixed window size, which is going to be of length p. We want to go through our string and find all anagrams, basically. And the way we'll keep this linear, as opposed to quadratic, is by actually adding and removing strings from a shared dictionary. So we always have a map of the characters in our current window dynamically. So let's actually get to coding this up, and it'll make more sense as we actually do so. The first thing we want to do is we want to say if length of string p is greater than the length of string s. Well, in that case, there's going to be no reason for us to carry on. It's impossible to actually find an anagram, so we're just going to return an empty list. Otherwise, we want to have a result list, and let's create a dictionary called pdict, which is going to store in all of the characters, or basically a map of all the characters and their counts in the string p. So we can say for each character in p, pdict c equals pdict.get. We'll get c and we'll get 0, and we will plus by 1. So what this will do is create a map of each character mapped to the count of that character in the string. The next thing we want to do is create a window size. The window size is going to be the length of string p, as we discussed, and the window size, and we also want the window dictionary. So the window dictionary is just going to be equal to empty dictionary initially, and then we can say for each character in for each character in what will be the first window, we want to initialize our window. So we basically want to say for each character in s and slice all the way up to window size, and we'll just copy and paste this line over here if I can. There we go. So window dict, good. Okay, so that's our window dictionary built. The next thing we want to do is we want to say if window dictionary is equal to pdictionary, well, we found our first anagram. So we can say res.append 0, because the index is going to be a 0 for this beginning window. Otherwise, we want to say for I in range of string string window size up to the length of s. Yes. What we want to say is let's add to our window dictionary the new character which is at the far right of our window, and remove the character that we've just passed. So I'm just going to copy this code over here. Window dictionary character in string s at position I. Do the same here, and then we can just say minus equals 1, and actually we want to say minus window size. So the one at the far left, that we've just passed and that's no longer in our dictionary. We want to decrement by 1. And we also want to just totally delete it from our hash map. We don't even want to store it as 0 if it is equal to 0. So we're going to say if it is equal to 0, the count of this character is equal to 0, then we're just going to delete it. Fab. So that's that logic out of the way. Then all we have to do now is actually copy this line over here. But instead of actually just appending I, as you want to say I minus window size plus 1. And the reason we want to do this, we want to get the beginning index of our anagram. And then we can just return our result. So let's check that code actually works. And it does. We pass all 65 test cases for this problem. So in terms of time complexity, guys, we're looking at a big O of n time complexity. That is a terrible O. Big O of n time complexity and big O of 1 space complexity. And with that being said, I hope you guys enjoyed this video and I'll catch you in the next one.